Welcome everyone. Today we are solving problem 7.50 from Sadiku book. The problem says find Ix for t is greater than 0. So here in this circuit, if we calculate for t is less than 0, for t is less than 0, the switch, what it says, the switch will be closed at when t equals to 0 or t is greater than 0, right? The switch will be closed when t equals to 0, t is greater than 0, right? For t is less than 0, the value is lesser than 0. So the switch will be opened or it will be remains same. So if it's opened, then no current will be flow in this total circuit, right? In this total circuit, no current will be flowing in this total circuit. If there is no current flowing in this total circuit, then the voltage across these two terminals are equal to 0 because there are no current flowing in this whole circuit. So the current will be for this voltage for this capacitor will be 0, right? So for t is less than 0, the V0 will be 0. The V0 will be 0, right? For t is greater than 0, for t is greater than 0. If we want to calculate for t is greater than 0, now the switch will be closed. If the switch is closed, and let's just what to do? Let's just source transform this both of these. Let's just source transform both of these. It will be plus minus. It will be 30 into 1 equals to 30 volt. And here we will have a resistance. Let's just have that resistance here, resistance, and 1 kilo ohm resistance. And here we have open circuit, and here we have another resistance, and it will be as equals to this, right? It will be 2 kilo ohm, it will be 1 kilo ohm, it will be 1 kilo ohm, and it is plus minus V. We just source transformed these both of them, right? Okay. Now if for t is greater than 0, the switch will be closed and the whole circuit will be in a steady state form, right? In a steady state form. If the whole circuit is in steady state form, we can replace the capacitor as open circuit, which we did already. So the voltage across the capacitor or V infinity is now as equals to the voltage across 2 kilo ohm resistance, right? The voltage across 2 kilo ohm resistance and the voltage across the V are equals to same, right? Now we can use simply voltage divider or nodal analysis, whatever we want. So I'm just using voltage divider in this case. So if we want to use voltage divider for this, I mean this 2 kilo ohm resistance, because both of them are same. So for this V infinity will be, for this 2 will be using voltage divider, 2 divided by 2 plus 1 into total voltage. What is the total voltage? It will be 30 volt. So ultimately 7.5, 15 volt. So it will be 15 volt for V infinity. Okay, we got V infinity as 15 volt. Now let's calculate the value of tau. Tau will be for what value? T is greater than 0 or steady state form value. For tau, we know it will be RTh or RThevenin into C. So what is the value of RThevenin? RThevenin is across this capacitor, right? So across this capacitor, 1 and 1 are in series, so it will be 2, and these two are in parallel. So the R equivalent will be 1 plus 1 parallel 2, and with the multiplication of the capacitance voltage, the capacitance equals to 0.25 into, not just mention 10 inverse because millifarad and kilovolt will be cross out each other, so it will be 0.25 as remains same. So it will be 2 1 by 4 1 by 4. So it will be 1 by 4 second. Okay. So we can just write out the Vt value. So Vt will be V infinity plus V0 minus V infinity e to the power minus t by tau. Okay. What is the value of V infinity? We already calculated 15. This value will be 0. Let me just change my pen up. It ran out of ink. So if we calculate, this will be 15, this will be 0, this will be 0. So it will be minus 15 e to the power minus, what is the value of t? T will be t remains same, and tau equals to 1 by 4. So if we write this out, 15, let's just common this out, and 15 e to the power minus 40. So this will be the value of our voltage. This is the answer. No, wait, they haven't asked for this. They asked for the value of Ix for t is greater than 0. So we have already calculated Vt or voltage through these two terminals, right? Now let's just head back into this original circuit. We have already calculated this voltage across these both terminals, and they wanted us to calculate the value of Ix. Now if the switch is already closed, we can write it as the current through, let's say this current through this terminal will be IR. The current through this capacitor will be IC. The current through this terminal will be I2. Okay. For this, we can easily say 30, the switch is already closed. So 30 equals to IR plus IX, right? We can say using KCL, 30 equals to IX plus IR, right? We can say that, right? Okay. So let the calculation of IR, we wanted to calculate the IR value. So IR equals to what? 30 minus IX, right? Again, what is the value of IR? Again, what is the value of IR? What is the value of IR? IR equals to what? IC plus I2, right? IC plus I2. What is the value of IR? IR equals to IC plus I2. Again KCL. So IR equals to what? IC plus I2, right? So what is the value of IC? IC will be the current through a capacitor will be C dV by dt, right? We know already that C dV by dt, and the current through will be this. This will be what? V by 2, right? V by 2. The voltage across, we have already calculated the voltage across capacitor, which is ultimately this terminal. So V divided by 2 will be the current of this terminal. So it will be V divided by 2. Now let's just calculate. The capacitance is 0.25 into 10 inverse 3. We have to calculate d by dt of what? D by dt of this. So this will be 15 1 minus e to the power minus 40 plus V by 2. What is the value of V? We already calculated 15 1 minus e to the power minus 40 divided by 2. Alright, now calculate this whole out. It will be 0.25 into 10 inverse 3 into 15 0 minus e to the power minus 4 e to the power minus 40. Hold on a second, let's just rewrite this whole out. It will be 0.25 into 10 inverse 3 into 15 into minus 4 e to the power minus 40 plus 15 divided by 2 will be 7.5 1 minus e to the power minus 40, right? If we rearrange the whole thing together, it will be IR T equals to what? IR T equals to, let me just calculate this out, 0.25. Okay, here we have to use a minus due to the calculation for Lenz's law. So the value will be 0.25 into 10 inverse 3 into 15 into minus 4. Okay, the value will be all together with 7.5 each, so it will be also 7.5. So the value will be 7.5 1 plus e to the power minus 40 into 10 inverse 3, or we can call it as, wait a second, we can call it as 7.5 1 plus e to the power minus 40 milliampere. Okay, alright, we have already got IR. So what is the value of IR? IR will be, again we know 30 equals to what? 30 equals to what? 30 equals to IX plus IR. So 30 equals to IX plus IR, right? Or we have already gotten the value of IR, so it will be IX equals to what? IX equals to 30 minus IR. So it will be 30 minus, what is the value of IR? This. So it will be 7.5 minus 7.5 e to the power minus 40. So it will be 22.5 minus 7.5 e to the power minus 40 milliampere, because this unit is also in milliampere, so this will be milliampere, and this will be the answer for 7.50. I hope you guys already enjoyed the video. Thank you very much.